All right, so now we're going to be taking a look at the slope, but rather than having a picture, all we get are 2 points. And these 2 points are on the graph, and if we wanted to, we could draw a picture and draw the points on the graph to figure out the slope between the two lines. But this actually is not too difficult to kind of conceptualize in your mind. So again, we know that if we have the picture, or even with 2 points, we know that the slope means the change of y over the change of x. Meaning, what's the difference between the two y's and what's the difference between the two x's? So, we just need to find the change between them, essentially. And we can obviously see that on a picture. We just count how many goes up or how many goes down. But when we don't have a picture, we have to have some sort of type of formula or something to plug it into so that we can see it. And here's the formula that we use. It's called y2 minus y1 over x2 minus x1. It gives me the slope. Now, some people like to do just y minus y, x minus x, but what's important is you have to start with 1 point and take the difference from the other point. You can't mix and match. So that's why I like to be specific with y2 and y1. And what the 2's and the 1's mean, it's not an exponent. What it is a identifier. So which point am I talking about, or which y part of which point am I talking about? So y2 and y1. So for number 15, for example, I'm just going to arbitrarily label this first point is point 1, and the second point is point 2. And so think about it. If that's, so negative 4, negative 8 is point 1. That means the x part, negative 4, is x1, because it's the x part of point number 1. The negative 8 is the y part, and it's the y part of point number 1. So negative 4, negative 8 are x1 and y1 because it's the x part of the first point and the y part of the first point. So that would mean negative 2, 0. Negative 2 is the x part of the second point, and 0 is the y part of the second point. So I just like to label it like that because then it makes it real simple to plug it in to that little formula I gave you there, y2 minus y1 over x2 minus x1. Now, pay attention here on number 15 because here's what happens. I'm going to write y2, which is 0, minus y1, which is negative 8. So notice how the subtraction symbol, because again, I said, like the change is called the difference. The difference doesn't go away, meaning 0 minus. So when it's negative 8, you have to write both negatives, the minus and then also the negative 8. So I'm going to have 0 minus negative 8, very important that we write it that way, over the change in x, which is negative 2 minus negative 4. Same situation. Again, when we subtract the two different x parts, we have to include both the negative in the formula and the negative that goes with 4. Now, as we know, two negatives that close together become a positive, so then it becomes 0 plus 8, which is positive 8. On the bottom, we have the same thing. Two negatives that close together become a positive. And so we have negative 2 plus 4, which is positive 2. 8 over 2, we can reduce that to 4 over 1. And 4 over 1, again, if you wanted to write the invisible 1, you can, but if not, you can just write 4 as my slope. Now, when we graph, we do want to keep the invisible 1. It's very important. But if we don't want to graph, then 4 is just fine. We don't have to write the invisible 1. All right, let's quickly go through 16, 17, and 18 while we're here. So, for number 16, we'll just arbitrarily label the first point as point number 2, and 0, 0 is point number 1. But we still labeled the same. So the x part and the y part of point number 2 are x2 and y2. And that would make 0, 0, x1 and y1. So let's plug it in to the formula y2 minus y1 over x2 minus x1. That would give me negative 3 minus 0 over negative 3 minus 0. Negative 3 minus 0 is negative 3. And negative 3 minus 0 is negative 3. Now two negatives right over each other become a positive. And 3 divided by 3 is 1 over 1. So again, I don't have to write the invisible 1 down below, but I do need to write the 1 on top, so it's just 1. All right, for number 17, let's label 2, 5 as point 1 and 9, 1 as point 2. Label the numbers appropriately, and let's plug it in. So it's 1 minus 5, y2 minus y1, over 9 minus 2, which is x2 and x1. 1 minus 5 is negative 4, over 9 minus 2, which is 7. And a negative over a positive is a negative, so the negative stays. And 4 over 7 I can't reduce, so that's my final answer. All right, and finally number 18, we'll label 0, 0 number 1 and negative 2, 7 number 2. Label appropriately. Let's do the math. So y2 is 7 minus y1, which is 0, over x2, which is negative 2, and x1, which is 0. 7 minus 0 is 7. Negative 2 minus 0 is negative 2. Now, in this situation, we can't reduce it, but we always like the negative to be on top. Otherwise, it seems to be forgotten if we leave it on the bottom. So even though it's 7 over negative 2, it's the same thing to say negative 7 over positive 2. Because the fraction's still negative, it doesn't matter if it's on the bottom or on the top. And in math, we prefer to keep it on the top. So my answer for number 18 is negative 7 over 2.